In section 7.9, we are solving rational exponent equations. So these are equations, so they have equal signs, and they also contain rational exponents. Remember, rational exponents, that'd be like something like x to the 2/3 power, and then we have an equal sign somewhere in there. So these would be types of rational exponent equations. Just a reminder before we start is how we can change a rational exponent into a radical. So remember that your denominator is the index of the radical, and the numerator is the exponent that we would raise the base to. So I could rewrite this as the cube root of 8 squared. Now again, it doesn't matter if I put the squared on the outside of the radical or inside the radical. You can do it either way. You can take the cube root first and then square it, or I could square the 8 and then take the cube root. It is up to you, all right? Some ways are easier than others. In this case, I would say it's probably easier to take the cube root of 8 first, making it a smaller number. So this would give me 2 to the second power, because the cube root of 8 is 2. And then we know that 2 squared is 4. Here, if we have 25 to the 3/2 power, this is like the square root of 25 to the 3rd power. Again, you don't need to put that 2 in front. Okay, we assume that there's a 2 there with the square root. And again, I think it's easier in this case to take the square root of 25 first. So this is going to be 5 to the 3rd power, and we know that 5 to the 3rd power is 125. If I have 32 to the 1/5 power, well, this is like the 5th root of 32 raised to the 1st power, so we don't even really need to write that 1 there. But we know that the 5th root of 32 is just 2. 2 times 2 times 2 times 2 times 2. So when we solve these, we are going to have to be changing these rational exponents into actual numbers, so just be aware of that. First type of question you're going to see is we're just asking, is 9 a solution to this to this equation with rational exponents? So what I want to do is I want to plug in a 9 for x. So I'm going to rewrite this as 2 times 9 to the 3/2 power minus 19 equals 35. I'm now going to go ahead and see if this is true. So remember, this 9 to the 3/2 power, this is the same thing as the square root of 9 cubed. And we know that the square root of 9 cubed is just 3 cubed, and that's going to be 27, right? 3 times 3 times 3 is 27. So I really have 2 times 27 minus 19 equals 35. We know that 2 times 27 is 54, minus 19 equals 35, and we do in fact get 35 equals 35. So since this is true, we know that yes, it is a solution, all right? If you ended up with a false statement here, then that would be no, it is not a solution. Now we're going to get to somewhere we're actually solving these rational exponent equations. So the first thing you want to do is you want to isolate the base and the rational exponent. So sometimes your base is just going to be the letter x. Other times your base might be a binomial like this. So the base I highlighted in turquoise there, and then the rational exponent is, again, your fraction exponent. You want to raise both sides to the reciprocal power. So if I had x to the 3/2 power, I would want to raise both sides to the 2/3 power. The reason why is because when I do this, the 2 in the numerator and denominator will cancel out, and the 3 in the numerator and denominator will cancel out, leaving me with just the letter x. Same thing, if I had 5x minus 1 to the 4/5 power, I could raise it to the 5/4 power because the 5's would cancel and the 4's would cancel, leaving me with just a 5x minus 1. So this is a good strategy for eliminating those rational exponents. Okay, you have to raise both sides to the reciprocal power. Last thing you're going to do is anytime you have these rational exponents like the ones we did at the very beginning of this video, you're going to take your rational exponent, and to try to simplify it, it's usually helpful to rewrite it as a radical and then just simplify it to become a number. Last thing you want to do is just solve for x. Remember, your final answer should be x equals some number, just like that. And then, of course, check your answer. You want to check for extraneous solutions. So let's go ahead and solve these rational exponent equations. For the first one, we see that my base and rational exponent is not yet isolated. So I'm going to have to go ahead and divide both sides by 3 to begin with. All right, 3 is not part of the base. 3 is just a coefficient. And so we end up with x to the 5/2 equals 32. Now again, to undo this 5/2 power, I need to raise both sides to the reciprocal power. So I'm going to take x to the 5/2 power, and I'm going to raise it to the 2/5 power. Now, if I raise the left side to the 2/5 power, then I also have to raise the right side to the 2/5 power. Okay, you have to keep it balanced. Whatever you do on one side, you must do to the other side as well. We see that on the left side, 2 in the numerator and denominator cancel. 5 on top and bottom also cancel, so I'm just left with x equals 32 to the 2/5 power. Now I want to rewrite this as a radical. So this is x equals the 5th root of 32 squared. I'm now going to take the 5th root of 32, which I know is equal to 2. So this is really 2 squared, right? Same thing as 2. And we know that 2 squared is equal to 4. So we get an answer of x equals 4. Last thing we want to do is just double check to make sure this is, in fact, a solution. So we're going to plug in a 4. So we have 3 times 4 to the 5/2 power equals 96. So if I look at this right here, we know that this is the same as the square root of 4 to the 5th power. And this is equal to 2 to the 5th power, which is 32. So if we just quickly multiply that by 3, 3 times 32 does in fact equal 96. So 4 is in fact our solution. All right, for the next one, again, we want to isolate the base and the rational exponent. So I don't quite have that yet. I'm going to go ahead and do some work on this. We're going to first start by subtracting the 48 on both sides. All right, so that gives me negative 2 times x minus 5 to the 3/4 power. This is going to equal negative 250. All right, so I'm going to keep going now. I'm not quite isolated. I'm going to divide both sides by negative 2. And we now see that x minus 5 to the 3/4 power is equal to 125. All right. So if we get x minus 5 to the 3/4 power equals 125, we can then go ahead and raise both sides to the reciprocal power. So I'm going to raise this to the 4/3 power. I'm going to raise this to the 4/3 power. All right, we see that the 3's will cancel, and we see that the 4's cancel on the left as well. So that means on the left, all I have is x minus 5. And on the right, I can rewrite this as a radical, right? So that means we're going to have the cube root of 125 to the 4th power. And so now we have x minus 5 equals, well, I know that the cube root of 125, this is equal to 5, right? Because 5 times 5 times 5 is 125. And we know that 5 to the 4th power is 625. Okay, if I multiply 5 by itself 4 times, that gives me 625. So this equals 625 here. And then we're going to go ahead and we are going to add 5 on both sides. And once we cancel out these 5's, we find out that x is equal to 630. Okay, make sure you check your answer, plug it back in, and see if it actually makes a true statement. I did this earlier and I double checked, and it does work out. So x equals 630 is a correct answer. All right, for question number 3, we're going to go ahead and again try to isolate this base and the rational exponent. So I'm going to start by dividing both sides by 8. We can cancel out these 8's here. That leaves me with 3x minus 1 to the 2/3 power. And we know that 200 divided by 8 is going to be 25. All right, if I have 8 quarters, that gives me $2. So now I'm going to go ahead and try to get rid of the rational exponent. I'm going to do that by raising both sides to the 3/2 power. All right, we see that the 3's cancel and the 2's cancel for those rational exponents. That leaves me with 3x minus 1 equals the square root of 25 to the 3rd power. And then I want to change this up, right? We know that the square root of 25 is just 5, and 5 to the 3rd power is 125. So if 3x minus 1 equals 125, we're then going to solve this by adding 1 on both sides. That gives me 3x equals 126. And if I add up these digits, right, 1 plus 2 plus 6, that equals 9. So I know that this number is in fact divisible by 3. I should not end up with a fraction. I should get a nice whole number here. And so when we divide by 3, we find out that x is equal to 42. All right, 42 times 3 is 126. Again, you want to plug this answer in to your original problem to make sure it does work. I did that earlier and I checked and it does in fact work, so we do get an answer of 42.